case. Another case, if they are both positive, right eyes is 0.5, left eyes is 4. So what's the difference? 3.5. So above 1.0 diopter. So this is also anisometropians. Some patients is one eye is minus, like this patient, right eye is -1, left eye is plus, right? This is above is 4, so it is also above 1. So they are also anisometropians. All right, I will go back this slide later. So what is the antimetropia? Antimetropia, that means one eye. Anti means is different. So one eye is myopia, another eye is hyperopia. Because when we write in the prescription, myopia normally is minus, hyperopia normally is plus. So it is one eye is minus, one eye is plus. Therefore, we can call that anti. So let's see this patient. Right eye is minus 0.25, left eye is plus. So one is minus, one is plus. So we can definition this patient has anti because they are different. Another case, like this case, one is plus, one is minus. Also, this is anti. However, let's see this third case. One eye, right eye is plus one. The left eye is minus. All right. So one is plus, one is minus. This patient is antimetropians. And also, these patients can also the anisometropian. Why? Because right eyes and the left eyes, they are different in 3 diopter. That is above 1 diopter. So a patient can be either antimetropian, that means one eye may be myopia, another eye may be hyperopia. At the same time, their difference may be above 1 diopter. So we also call this anisometropias, right? So let's go back to formal slide. To see this patient, right eye is -1, left eye is +3. We already know this is a 4 diopter difference between the two eyes, above 1. So this patient is anisometropic at the same time because one eye is minus, one eye is plus. So they also make this patient also have these definitions, antimetropian. So therefore, a patient can be either anti or aniso. But however, the patient can be have both. Both is anti and both at the same time. Also above 1 diopter. So this patient can also have aniso. All right. So this is a very simple idea. So in the future, when we give you a patient's prescription, you need to make this judgment. Okay. So let's talking about the visions. Most of our students in the future, when you go to the clinical, the patients you meet will be the myopic patients. So what is the myopia patient's eye they see? Let's see the left this vision skill card. So in our normal patients or normal student, if you wear your glasses, sit in front of the screen, right? You can clearly see the number from the 2020 to 2200. However, if you put the 1 diopter, the lens, or this patient has one, no matter plus or minus, you can see the vision is blurred. If they have 2 diopter, 3 diopter, make the image is harder to identify, right? The simple experiment is if you wear glasses, you just take off and you can see what is the difference and what is the real world in the myopia patients, right? So what is the astigmatism patients can see? I think maybe 30% of our students, all right, or maybe to 50% of our students. When you have the myopia at the same time, you also have astigmatism. Astigmatism, that means one axis is more blurred than another axis. For example, in the first one, A, B, and C, D, you can see in the astigmatism, apparently in the horizontal you can see is relatively clearly than vertical image. In the vertical image, you can see there's a blur. So in here, we can see that the vertical line is more blurred. So this is the astigmatism patients, the real world, right? One axis is more blurred than another. So let's see this layer. This layer, you can see apparently the vertical layer is more clearly, right? In the horizontal, you can see is more blurred. So horizontal line in these patients is more blurred. So they have the more power and the more problem. So what is the blur circle? The blur circle is a focal when we talking about the astigmatism or the myopia and whatever. They are focused on the retina, right? Maybe probably caused by the aberration of the image optics. So in simple, if an image is perfect focus on the retina, they should be a point or is a perfect match of the image. However, most of the time it's not the case. So they will making the blur circle. So what is the blur circle? So let's see, the first is the normal patients. Infinity light through the, which is, this is reduction eyes, through the corneal lens of vitreous, if their image can perfectly focus on the retina, they will a very small or even a dot image. However, if for some reason, like this patient, like hyperopia, they cannot focus on the retina. They either focus front or behind. Then they will make a circle like this. All right. Use a pinhole. Actually, you can look at the target again. You can through that. So let's see the blur circle, how they change. The size of the blur circle, you can see a little bit different. So how they change. Let's see, this is figure A and the figure B. The figure A, right? They making some the blur circle. For example, this patient has what? The myopia. So when the coming image coming from the infinity, they focus on in front of the retina. However, they projected on the retina a blur circle. So this is the size. Compared to this myopia, they have the same power, right? They have the same distance. However, these patients have a large pupil, and this one has a small pupil. The small pupil normally make a small blur circle. Think about the pinhole theory. When the pinhole is small, actually they can get rid of this myopia. So the same. So when the pupil size become large, they have a large blur circle. When the pupil size decrease, right, they will have the small blur circle. Then let's see the B and the C. And the B and the C, what's the difference? They have the same pupil size. What's the difference? The difference from these two patients is that in the figure B, they have less power. When they have the less power, that means the distance to the retina is close, right? So they have the smaller blur circle. However, if these patients have a strong myopia, so they have focus far away to the retina. They have strong power, right? They make it focus far away from the retina. So what's happened? The distance is a little bit far away to the retina. Therefore, their blur circle also become bigger. So compare these two images. So let's make a little bit of summary. All right, about the blur circle, their size of the retinal blur circle. That means the image projected on the retina, making the blur circle, is depend on first figure A and figure B. If they have the same power, if they have a big and large pupil, normally they have the big size of blur circle. All right. If the black image B and C, if they have similar pupil size, so the blur circle size will be relative to the power and all the distance from the retina. If the distance from the retina is far, that means their blur circle will become bigger and larger. All right, so this is the, we need to understand the blur circle and their the size, how they change with the pupil and how they change to the distance to the retina, actually change with the myopia power. So let's see about the astigmatism. How do we understand what is the astigmatism? So let's go back. If the retina, we have a circle of the ring, right? If the retina, we have the astigmatism, that means in the horizontal and the vertical, they have a different power. They have the different power. So for example, like this patient, the first is focal line, which is horizontal, is close to the circle. The circle, that means this image will be more clearly. If the second one is a little bit far away, like this is vertical far away, that means this one is more blur, right? So reflection in the astigmatism image, so horizontal should be more clearly because in the horizontal power, they close to the circle of the visions, so they should be more clear. However, if this one is far from that, then they will make more blur, right? So this is this image show is the vertical line is maybe more blur. However, if you think, if we're moving this line closer to this circle, making it more close than this horizontal, then in here, in these situations, then in the vertical line, in this direction, the image should more clear compared relatively to horizontal image will be more blurred. So that is how we understand astigmatism patients, their image in the different axes, how their image blur. All right. Okay, I want to stop here a little bit. I want to go back to ask our student. So far, any questions? So we all understand, right? If you have any questions, please let me know now. Any questions? I think it's clear, right? Okay, good. I'm going to moving on because next I will talking about a little bit complicated things. Okay, so I assume our student understands this. All right. Then there was a different type of the astigmatism. Let's see. We can convert line from the stepper, which is more power meridians, coming to the different way. For example, like this one, image. Think about these patients if they have the astigmatism, all right, or hyperopia, for example, like these patients. In these patients, they have image like a cross. When they through the eyeball, they project it behind of the eyeball. In the horizontal line, they are more close to the retina. In the vertical, is a little bit far away to the retina. So what kind of this patient is? We call that compound hyperometric astigmatism, all right? Because they have